Welcome everyone on this fine Saturday morning. By now, everyone knows that I am Jade Irving. I'm the program coordinator for the First2 Network, and I'm just super excited to introduce you all to our research and evaluation team. They're going to be sharing with us this morning about the successes and the challenges of the First2 Network so far. So I'm just really eager, looking forward to hearing what they are going to share with us, and I hope that this will be as enlightening to you as I know that it will be for me. So with that, I am going to pass it to Gay.
Hi. So I'm Gay Stewart, and I'm the First2 PI at WVU, which leads the research effort of the proposal. And we're going to be the first half of the presentation, and then we're going to move into the evaluation. As you may know, NSF does not fund good work. They fund learning opportunities, and First2 is one of the biggest experiments they've ever run. What they're includes the overall program. What they're really looking for is learning how to ensure that this kind of change happens, is sustainable, and is adopted by the community. So we're very excited to be part of helping NSF learn these things. Our first presentation will be our qualitative research lead, Marjorie Dara. I'm going to let her finish introducing herself. Thank you.
Hi, I'm Margie Dara. I am the chair of mathematics at West Virginia University, and I'm on the research team, the qualitative side. I'm going to start my screen sharing. Hopefully everything works. And let's see. Okay, I think this is what I want to share. We'll see. Okay, and then I think, let's try this. Okay, I don't know why it always starts with that slide. That's slide 5. Okay, can everybody see my first slide, which says First2 Network Qualitative Research Team Success? Okay, good. All right, and I will be presenting with my co-researcher, Roxanne Humbert, and then we'll be followed by John Stewart for more quantitative research. Today, we're going to talk about network analysis and rural area analysis. The questions that we have, research questions that we have around network analysis, this is what I'm going to be talking about first, are what types of meaningful networks are forming among the entities within the state of West Virginia? What are the structures of the relationships that are forming? And what are the best ways that the network can share knowledge and resources to assist students to persist in STEM? Now, we haven't answered all these questions, but we're doing some things toward answering them. I wanted to take just a minute to start to talk to you about what social network theory really is. It's based on graph theory, and it's applying graph theoretical techniques to social situations. Graph theory is a branch of mathematics that studies virtually dots and lines. There's literally a textbook in graph theory called Dots and Lines. And I did my PhD dissertation on graph theory, so it gets a little more complicated than just dots and lines. But you can see two pictures here. The top picture is just a simple graph, and then the bottom shows a very complicated graph structure. I want to start with a little animation to show you how our network has been growing. The red lines, the graph with the red lines will be 2018 network of First2, and the blue lines will be and people will be the 2019. And we're going to show the graphs first separately, side by side, and overlaid, and in different ways, so you can see how the network is growing. You see many more connections in 2019, the blue lines. Here they are side by side. See the more people, more connections. It's a different way of looking at it. You can see people at the top, large people with lots of connections. And then the 2019, we have more larger people and larger connections. These are the numbers in 2018, and then the blue people coming in will be the 2019 people. I need some music behind this, right?
Mm-hmm.
So you can see you know, graphically that our network is definitely growing. The connections are growing. But let's talk about how we analyze this. So here are methods in looking at the social network within our state. First, we developed a social network survey that we sent out. It was developed by the research and eval teams. We delivered the survey in an online format. The informed consent page was at the beginning. We collected demographics about you, which was your name, organization, your role in the organization. But then we asked you to tell us 10 people in the network with whom you communicate. And then we asked you to rank those connections based on the following scale, which were given more definition within the survey itself. One was represented just networking with these people, and all the way up to 5, which was collaboration. This is based on some work done by Hoag, Borden, and Perkins in 1999. We used their scale here. I wanted to clarify that you would appear in that network. So that drawing that you saw, you were one of those if you either filled out the survey for us or you were named by somebody who did fill out the survey. And the survey was administered to, or was sent to everyone in 2018 who attended the First2 conference, and in 2019, everyone who was, well, invited, not attended, everyone who was invited to the 2019 conference. And again, you will be sent the survey soon. I'll remind you at the end that, so it doesn't mean that if you didn't fill out the survey, you aren't in the graph. You would end up in the graph if someone named you also. Okay, let's talk about the measures we used to look at this graph. First, we looked at things like density, centrality, clicks, social conductivity, and robustness. These were just a few of the measures we looked at. I'm going to go into a few of these measures in depth and show you how they were applied to the network. Okay, let's start with degree centrality. This measure quantifies how many connections a person has to other people in the network. We developed what's called a weighted graph. And it's like the figure from the slide you see here, so that each connection has a weight on it. So if 2 people are connected, there's also a weight, and that was based on what you told us your connection was with the other person. Okay, so to look at this graphically, if you look at degree centrality, here we're showing a different way to look at the graph, and you see that certain nodes, which are the people in the graph, are larger than other nodes. These are people that have more connections and stronger connections, because the size of the node is based on not just how many connections, but the numbers associated with those connections. And those are added up, they're summed up, and then that's how the size is developed. So you can see in 2018, we had a few large nodes in the center of the graph. These are people with lots of connections and strong connections. But in 2019, we have many more people central to the project or to the network in the state. And then we have many more people on the periphery being added. Sorry, skipped a slide. Okay, so this is a way to look at degree centrality numerically. So we noticed that the number of nodes grew. Again, we know how the nodes get added to the graph, but the DC sum, or the degree centrality sum of the graph, which is adding up all the numbers for each of the nodes, went up considerably from 2018 to 2019. And then the DC mean, which is the average person, their degree centrality also went up from 2018 to 2019. Significant. Well, I'm not going to say significantly because I haven't checked significance here, but it considerably, I'll say. Okay, let me talk. The next measure I want to talk about is closeness centrality. Okay, closeness centrality focuses on how close each person is to all other people in the graph. The nodes with the high closeness centrality can reach a lot of other people quickly and spread information through the grapevine. So we can, again, see another depiction of the graph, and the size of the node and the color of the node also depict higher closeness centrality. So you can see on the periphery, in this picture, there weren't very many large nodes, but as you see in 2019, the connections have increased greatly, and the size of some of the nodes have increased. So for example, this node here can spread information through the network quickly because they have connection to many, many people within the network. That means that they named 10 people, but then lots of other people named them as one of their connections. Okay, now closest centrality is a little bit more complicated to compute than the degree centrality. I gave you the formulas below, but I won't go through them, but I just wanted you to see why the numbers look different on the closeness centrality sum. It's actually an inverted number, so the numbers are going to be low. But the idea here is that the number did go up. So you can note that the CC sum went up slightly from 2018 to 2019, indicates that in total people are a small amount closer to everyone. And then the person with the max closeness centrality prime is the same person in both years, and this person is on the research team. It also, we can notice that the CC prime sum and the CC prime mean both increased from 2018 to 2019. And the variance increased a little bit as well, meaning it's a little more variable because we have some new people coming in who aren't close to many people, or we might have some isolated nodes, which are people who maybe have just named themselves, but nobody else in the network, or maybe they filled out the survey the first year, but were carried over to the second year. Okay, the next measure I want to talk about is the click comparison. Click is the largest subgroup largest complete subgroup of nodes. So it shows a very close-knit group. So you can see the picture of the clicks down at the bottom of the screen, size 3, size 4, size 5, and size 6 here. For the First2 network in year 2018, we only had 13 close-knit groups of size 3, and we had 6 close-knit groups of size 4. But by year 2019, we can see these close-knit groups greatly increased. So we had in 2019, we had 21 size 3 clicks, or group 3 size 3 that were closely knit, 34 of size 4, and 11 of size 5. And I would attribute this mainly to the close relationships and collaborations that are being established in the working groups and the leadership team. Okay, so I want to talk just briefly about the new measures that were developed by our former grad student, David Book. He is now doing his PhD at Duke University in statistics, but he did this work as part of his master's thesis. The new measure of social conductivity is modeled after the idea of series parallel resistors in physics. And we have at least two physics professors on the line, so maybe they can relate to this, or maybe they can correct me on this, but David had a background in physics as well. The idea is to look at the paths, all paths between two people, not just the direct connections between them, but look at all paths between two people and give that connection a number. The robustness of the graph looks at the paths between two people, but it takes out the direct connection. So that means if one direct connection is broken, how robust is the graph as far as getting information to those two people that are now disconnected? So I want you to go back and recall what our ratings for our connections were. 1 was networking, all the way up to 5 as collaboration. So this is what the social conductivity and robustness are based on. So in 2018, on average, an average person, would have rated a connection or average pair, sorry, I should say, would have the rating of 2.68, which is in cooperation. But in 2019, that average went up to 3.12. So overall connection. So that went from cooperation to coordination, a deeper relationship. And then the overall robustness of the graph, once these direct connections were eliminated, also went up. So the graph became more robust. So if certain direct connections were severed, that didn't mean that these people would be left out of the network, because the network is robust. So what are the conclusions that we can draw from all this information? Well, first of all, we can, the preliminary findings show that the network is growing in the number of people and the strength of the connections. It shows that several of the graphs show leadership members right in those larger dots. So it shows that the leadership members are playing key roles within the network. There are more people in the network, we saw that, and the ties are stronger. There's more nodes on the perimeter. In some of those graphs, we saw a lot of new, smaller nodes. That means that new members are being added. The graph density, social conductivity, and robustness all went up. And so there are more ties and stronger ties. The clicks increased, showing there's more close-knit groups. And both the average shortest path and the diameter, which I didn't really talk about, decrease, which signals that the ties are closer, that more people are connected to each other. Now, I went through this very quickly. So we do have three articles and presentations. We have a white paper which we developed for First2 just for the leadership group, but we also have submitted a journal article now to the International Journal of STEM Education, and this month we're going to be presenting at the American Evaluation Association about this. So there's my contact number. If you want to have more information about this, I can send you one of these. And please, I want to implore you to fill out the social network analysis survey so we can watch the graph in 2020 grow even bigger.
Okay. Thank you, Margie. I have a couple of quick questions, which we're going to try to plow through because, of course, we're already behind. First off, everybody said cool. They love the graphs. The node colors. Yes. What does the color represent?
For example, the red versus orange, as the intensity of the color, you could see the size. The size and the color are coordinated. I guess it's just two ways to show the same thing, that this is a bigger,
Okay, we weren't sure if there was maybe something different about those two. The other questions mostly revolved around students. Now, since they are invited to the conference, we're assuming that this network analysis includes the students?
It does include the students, and not many of them filled it out, but Joanna did help in 2019 getting the link out again to the survey out. We also put a social networking component in the student survey that we'll be sending out very soon, so that we can look at just the students' answers. So if if we get enough of the students to fill out the student survey with the social networking piece, then we'll be able to look at their graph separately.
Okay, because there were some questions about how many of these nodes were actually students, and if there was any way or the reason that maybe they couldn't be portrayed in a different way so that you could tell which ones were the students.
Absolutely, and I thought of that before the presentation today, that we really could put industry in one color. We did this on a graph before, industry in one color, students in another color, faculty. So next year that'll be coming. I'll make up a representation that looks like that. If Leah's on the call, our graduate research assistant, I should say at this point, Leah McGilton and Kim Cowley also were engaged in this research. Kim is from the evaluation team, and Leah is our graduate research assistant who did the cool animations.
Okay. All right. Well, thank you, Margie. I think we will now move to Roxanne, and because we're running behind.
Sorry about that.
No, it's great. We were late getting started, and again, people just type your questions in, and I'll try to make sure we get them all answered.
Okay, well, thank you, Gay. And I am Roxanne Humbert, and I'm also part of the qualitative research team. Um, and so, as you may recall from the last meeting, we focused on one of the research questions that dealt with first generation. This time, we're focusing on the rural component. And our questions were, can we better classify the locale where student participants lived in during their middle and high school years by identifying resources available in the area or cultural factors? And then what resources do students have access to that would have affected their decision to attend college or pursue STEM? We looked at things like museums, mass transit, etc. Next. So we spent a lot of time doing data collection this time. So first we looked at federal definitions of rural. We quickly found out that they really weren't very useful to us. Most rural classifications were based on population size, or they were based on free and reduced lunches in the terms of high schools. So we began to create our own spreadsheet with research on locales. We started with RUCC codes, which I'll explain a little bit more, as our baseline, and then we correlated with numbers and types of high schools, post-secondary institutions, libraries, museums, and public transportation. Next. Next, Mark. Oh, thank you. Okay, so the RUCC codes are called the Rural Urban Continuum Codes, and they were developed by the United States Department of Agriculture. They go from 1 to 9. And what's really kind of confusing is the higher the number, the lower the population or rural or metro area. And so when I looked at all this, I thought, how can I frame it for today's talk that might make sense? So for all of our correlations and all the comparisons I'm going to make, I'm going to focus on the RUCC2 counties, which according to the code are counties in metro areas, not with populations, but in metro areas of 250,000 to 1 million in population. And in West Virginia, there are only 5 counties that meet that criteria. And you can see those listed here: Berkeley, Cabell, Lincoln, Putnam, and Wayne. Next. So first we looked at high schools, and I got this information from the West Virginia Department of Ed. We looked at how many high schools were in a county, and the counties in West Virginia have anywhere from 1 to 5 or more high schools. And you can see that Harrison and Kanawha County have the most. They're the ones in purple. Those with 1 high school are in red. So in looking at the counties with an RUCC code of 2, they had anywhere from 1 to 3 high schools. So the RUCC code was no indicator of the number of high schools an area might have. And so you can see that our correlation, and again, all of our correlations are negative, because as the R numbers go up, the RUCC numbers go down in terms of population size. So the lower the number, etc. So then we looked at post-secondary institutions, and I got this information from the National Center for Educational Statistics. And we have counties that have no post-secondary institutions that are in red, and again, counties that do have post-secondary institutions are in blue. And again, those with an RUCC2 code had anywhere from 0 to 3 post-secondary institutions. And post-secondary include 4-year schools, community colleges, etc. Next. So then next we looked at libraries. And we had counties that had anywhere from 1 to 2 libraries. We got this information from the West Virginia Library Commission, so we looked at public libraries. And so we also looked at libraries that were distinct, like perhaps the Mother's Day Museum. I'm sorry, that's museums. I'm messing myself up here. So we'll just go back to counties and libraries. So the counties with an RUCC code of 2 had anywhere from 3 to 10 libraries. So like, you know, if we look at Morgantown, there's lots of libraries, one at the Med Center, one at WVU, etc. So that's why they had more libraries. But RUCC codes of 2, 3 to 10 libraries. Next. And we looked at museums, and this is where the Mother's Day Museum and those sort of things come in. And so counties had anywhere from no museums to 7 or more museums. And this was tough information to find. I went to the government sites that should have this information, but nobody had a comprehensive site. I did find this wonderful source on Wikipedia that had list of museums in West Virginia. And I'm sure it changes periodically, but at the time of our study, we had 0 to 8 museums for those counties that had the RUCC code of 2. And again, very low correlation. You can see the correlations for all of these with the RUCC codes are very, very low. So we know that the federal codes that we're looking at really do not have much to say about the ruralness of our counties in terms of what we're hoping to look at. Next. So next we looked at public transportation, and this information comes from the West Virginia Department of Transportation. And again, counties with RUCC had anywhere from 2 had public transportation and some did not. We only had 1 county that had more than 1 form of public transportation, and that was Kanawha County. So those in red have no public transportation. Those in blue have 1 source. Next. So we put all this into a nice little analysis and came up with our proposed rural codes. To be honest with you, we don't think they tell us much yet. You can see that we did do the comparison of the RUCC2s. It put 3 of ours in our coding of 3, 1 in 4, and 1 in 2. But we don't think it really tells a story yet. So next. So another thing that we decided to look at were the high school AP classes that were offered in STEM fields. So we found out that there were 380 courses offered in 2019-2020 in these various disciplines. So biology, there were 56, calculus AB, 84, etc. You'll also note that the ones that I have an asterisk, that at least 1 section was offered on the virtual school, and those with 2 asterisks, at least 2 sections were offered on the virtual school. And it's my understanding that students from any of the counties can take classes on the virtual schools. So the ones listed in the chart are ones that are physically offered within counties and then highlighted for the virtual school. And next. We did find 6 counties that had no offerings of AP courses, any of the science STEM related AP courses. And you see those listed there. This information all came from the College Board. So we still don't think we have all the information we need. Our biggest challenge, and one of the things that we wanted to look at, and one of the questions we asked for in the survey, was what type of STEM activities did students have access to in their high school and in their counties. And I know there are now some organizations within the state who are looking at this. So hopefully we'll be able to add that to our mix in determining our new codes. The other thing, the RUCC codes are from 2013. They've not updated them since. And so we figure that might be an indicator in terms of our correlations, but I'm not sure that's even relevant. And if we're going to continue to use that, we just needed a starting point to start looking at how our counties differ from these federal definitions. Next. So moving forward, again, we have groups working on trying to identify STEM activities by county. And then we're hoping to take this information and do an analysis against the First2 network. So the counties that these students are from, that decided to enter STEM and persist in STEM. Next. And to begin looking at that, our quantitative research team, we handed our data over to them, and John began looking at it in terms of the students that he was looking at in the quantitative study. And so now I'll take questions, I guess, and then we'll turn it over to John to talk more about that.
Okay, the couple of questions so far, they want to know if dual credit classes were counted in any way here.
They were not. We did not look at dual credit, but that's a good idea of something that we might want to add.
Right, because especially Julie pointed out that, you know, around Charleston, there are a few AP classes because they're offered as dual credit. And also there is some interest in tracking, I mean, do we do anything to track like the availability of STEM jobs in those areas?
No, and I don't know that that was something that we originally intended to look at, but
Yeah.
we will put that under consideration. I'm writing these things down so we don't forget.
Yeah, And there's some suggestion that, you know, we have some students that that can apply for money as researchers, that they might be able to do things that could be related to this, kind of submit data for an evolving citizen science project kind of map. And I've
Great.
told people to reach out to you guys that want to know more about, you know, your museum work. Okay, I'm not seeing anything else that's directly a question for these guys. Did I miss something? Oh, the score on AP exams would be something worth looking at. Not just how many people took it, but how many people got a qualifying score was a suggestion.
Yes, the College Board offers more data on these AP, but I do not have the authority to ask for that. So I may need to rely on you or John to try to get that, because you have to be someone from an institution, which
Okay.
I'm, so.
All right, we will happily help you with that. And speaking of, we'll now transition to the quantitative research, and that's led by John Stewart.
Hello, everybody. Let me take a chance to get this set up.
And I'll continue to try to.
So I'm John Stewart. I mostly teach. I mostly teach physics at WU. This work was done with the graduate student physics W. Elaine Crispin and with Roxanne Humbert, and with some input from Margie. And we took the variables that Roxanne just talked about, and we tried to see what their effect was on students' college success. Let's see. So our goal is to understand general features of growing up in a rural county, access to STEM enrichment opportunities like the museums and you know, public transit and things like that Roxanne talked about, and then access to advanced college preparatory coursework, which we'll quantify as access to AP classes. And we do have data on the amount of AP credit acquired and the amount of transfer credit, which would be generally for these will be first-time freshmen, so those will be generally dual enrollment classes. All right, so we drew a sample from WVU, all undergraduate students from 2008 to 2018, and then we threw away a lot of students, keeping first-time freshmen. We are focusing on those who are pursuing engineering and physical science degrees, and the two talks I'm giving, I couldn't order them, so we'll find out why that's the case in the next talk. But this is a nice cohort of students to look at because they have intensive course requirements and pretty stable course requirements. They might particularly benefit from academic enrichment opportunities. We grabbed a lot of variables from WVU, like things like college GPA and high school GPA, ACT scores, and then how much AP credit they transfer to WVU. So these would be AP classes where they actually did get a qualifying score, and then how much transfer credit they had, which for first-time freshmen would generally be dual enrollment classes. And then we got variables from the government. So, and I'll talk about how we get the rural fraction, but we know the fraction of students in a county, people in a county living in rural areas. And we can figure out the fraction of the county high school students who were classified as being of low socioeconomic status. So what fraction of the high school students were poor. And then I have lots of variables we got from Roxanne, like the access to AP classes, which is the mean number of AP classes offered in county schools that offer AP, and the AP STEM classes, whether they offered AP Cal, AB, AP Chem. And we looked at those two courses in particular because those are the primary first semester barrier courses for the students we're looking at. And then what fraction of schools actually offer AP. And then the variables Roxanne was discussing in her talk, and these are all at the county level. And we did some averages. It's an unreadable table, but the things like transfer credits and AP credits these are quartiles over here. They're very skewed. So lots of students have no AP credits and no transfer credits and no access to any AP classes. And likewise, this is the distribution of the civic facilities that Roxanne talked about. Every county had a public library, but you know, many counties didn't have academic libraries or museums or STEM museums. We only looked at calculus AB. So this is where I'll let Gay give me talk. If I go back and forth, it's gonna be insanely confusing. It's gonna be insanely confusing anyway, probably. So we have a lot of variables, and we'd like to know, really too many to work with. We'd like to know how they vary together. So we used a quantitative technique called a factor analysis to figure out which variables kind of went together, kind of the Sesame Street, these variables are like the others. We found 3 factors. One of them was all AP variables except the high school AP access variable. And we couldn't make that variable do anything. It didn't predict anything at the college level. So the other 2 factors were the ones we used, and they explained 64% of the variation. And here are 2 factors. So this is the factors loading. I know almost all of you are not factor people. So the rural fraction loaded on both factors pretty strongly. We named the factors. We named the first factor rural disadvantage because having more low SES students made the factor go up, and having less AP access made the factor go down. And then factor 2, we named lack of civic facilities because having more of any of those civic facilities made the factor go down. And so we can take these variables and we can see how they affect college success. And so we're going to use a statistical framework called mediation. And the idea of mediation is these variables could affect college success through a couple of paths. They could affect college success directly without affecting other variables, or they could affect college success by changing high school success. And we know high school success affects college success. So we're going to look at high school level things as mediators to the effect of these variables on college success. And we found different stuff, and I'm always surprised when, how this stuff goes. So this is a path model. I'm going to have to show you how to read it. So these are all in standard deviations. So this is our rural disadvantage variable. If that goes up by 1 standard deviation, the high school GPA of the student goes up by 0.03 standard deviation. So a decent size, a small effect. If rural disadvantage goes up, the amount of transfer credit transferred goes up substantially, and the amount of AP credit transferred goes down. So all these variables, but this number here, this minus 10.10, that's the effect of rural disadvantage on college GPA without any other variables. And if we throw all these high school variables in the mix, this minus 0.09 is the effect with all the variables. So the various high school variables don't change the effect of this rural disadvantage, having more fraction of rural students, more low SES students, and less access to AP over the high school variables don't explain the effect of rural disadvantage. So it continues to play out in college. I should note that 0.1 is not a big effect. So while there is a effect of growing up in more rural counties, it's not very large. And you can see here, the high school variables have dramatic effects on the college variables. Like high school GPA has a huge effect on college GPA. And credit and math, your AP and ACT scores have a smaller effect, and transfer credit doesn't seem to have any effect on college GPA. Okay, so that's the first one. And we can quantify this, so don't read any of the table. This was in the papers. And this paper has been submitted to AERA. We haven't heard back yet. So 16% of the effect of rural disadvantage did go through high school GPA, and for a positive effect. But there was kind of an offsetting negative effect on AP credit. So those 2 effects kind of washed out. So if we go to the second variable, which represents access to these various civic facilities that might promote STEM learning, we see something totally different. So first, overall, small negative effect, somewhat smaller. But when we corrected for the effect on high school, it became a positive effect. Okay, well, I'll take questions from the chat at the end of the talk. So, but when we corrected for all the high school stuff, it became positive, which was a bit of a surprise. And you can see
John, let me
the lack of STEM facilities have a negative effect on high school GPA.
let me interrupt you for just a minute, John, because people are really confused about positive and negative.
Okay.
And so how does AP credit have a negative effect? I didn't see that. Somebody wants to know.
So it's the sum of this past. So the lack of civic facilities here have students have lower AP credit, less AP credit. But AP credit itself has a positive effect on college GPAs. So the overall effect of lack of STEM facilities through this path is negative because the product of that number and that number. So overall, lack of STEM facilities depresses college GPA by depressing the amount of AP credit you have. Did that clear some things up?
Does that clear it up, Sue Ann? I can't see your thumb, so.
All right, and if you go back to the previous slide, you can see that AP credit in both slides does positively, just AP credit itself positively affects college GPA. And I should note in this slide as well, the transfer credits effect on college GPA is positive, but it's much smaller than the effect of having AP credit. Okay, and this also means this means that the students in counties that lack civic facilities are overcoming the high school disadvantage they get in college. And so most of this effect of civic goes through the high school GPA though. And that's because high school GPA is just so important to college GPA. So a small, small decrease in high school GPA will push a large decrease in college GPA. I think we put absolute values down.
So John, people are really concerned about what of these numbers should they pay attention to? I mean, a lot of them look tiny.
That's the first message. They are tiny. So these various county level variables are not having a particularly large effect on college success. But they are having, they are one of a continuum of variables, right? This is, these are one of hundreds of county level variables. And so the effect that, as we suspected, there is a small negative effect of both having less civic facilities and being in more rural counties ultimately on college GPA. All right, and from the chat, the number of stars is how statistically significant the numbers are. So numbers without stars aren't statistically significant. Numbers with 3 stars are very significant. So I just kind of big picture here, and I think Roxanne covered this. These variables, if these variables aren't affecting college that strongly. So if we want to look for big effects of, being of a rural upbringing and not have access to civic facilities, this set of variables is not the one that is going to explain big differences in college persistence or college success of rural students. Okay. And if you want more detail on this, we do have a paper that is submitted on it. So kind of the big takeaways are general features of growing up in a rural county, including a higher fraction of having low SES students in high school and less access to advanced high school coursework has a negative effect, 0.1 standard deviations on college GPA. And that's not explained by its effect on high school GPA or other high school level things. And the second one is the lack of STEM facilities, which might promote STEM intentions, had a small negative effect, but that's fully explained, in fact, over-explained by its effect on high school variables. All right, so I wasn't paying attention to chat, obviously, which I normally do in lecture.
Yeah, so there's some concern and questions around, okay, so AP doesn't matter?
Yeah, I mean, you can see AP was dramatically. So here, well, AP, in each slide, AP has a stronger effect on college GPA than transfer credit. But it is a significant, more AP credit gives you a 0.1 standard deviation higher college GPA, which is, and since AP credit is one of just tons of factors going into college GPA, and you can kind of compare it. It's not as important as high school GPA by any means, but it's kind of equal importance as your ACT percentile score. So, I mean, if your ACT math percentile score goes up by a standard deviation, it affects your college GPA, and AP credit does about the same thing. And once again, the transfer credit seems to have a much weaker effect on college GPA. And we kind of find that virtually universally.
Okay. And
John, do you mind just speaking for clarification to how you've got a 0.03 statistical significance between transfer credit and college GPA?
Certainly. So, and I didn't go over it. This is some time where you try to give a 30-minute talk in 12 minutes. So these basically, this is called, for those of you interested, this is called a path model. Each of these lines is a term in a linear regression. So to find all these things, I threw the variables transfer credit, AP credit, lack of STEM facilities, ACT math, and high school GPA as the dependent variables in a linear regression. And the college GPA was the independent variable, and these are the regression coefficients. And the statistical significance comes out of the regression. Did that answer that question?
Not quite, but it's okay. We don't have time. We can talk about it later.
All right. Okay, so now I can give the backward. So if there are no more questions, I can give the backward talk.
would it be
And Gay, how
fair-
much, so we have 11 minutes left. So how much do you want me to catch up on the next talk?
if you can go ahead and have your 12. We've talked about that. Would it be fair to say that there's this 0.03 effect, but we're 95% certain that it's real? Is that
Yes,
kind
that's
of,
what the
yeah.
1 star means. So
Yeah.
I'm sorry, I forgot to cut the significant codes into it, which to Elaine, I realized in the ARI paper, we put the significant codes on one figure, but not all figures. Yeah, so this is the 5% significance. This is 0.001, and the 2 star is 0.01 levels of significance.
And the overarching question here is really, what does this tell us we need to be working on?
What does it tell? Well, first it tells us focusing, I think tell us focusing on enrichment facilities at the county level may not be the right place where the big effects are. It continues to suggest that things like AP credit are important. And it also, I think, does strongly suggest that being a successful high school student, meaning that you have a high school GPA, is very important to being a successful college student. So those basic academic things, success in, encourage, really frame what does success look like in high school, and how encourage students who want to pursue these, and these are all physical science students, these advanced STEM course paths, encourage them to the right path through high school to be ready for that.
And the last clarification. So high school GPA, people were pointing out you can get if you don't take any AP classes, you might have a higher high school GPA because you took easier classes.
Normally AP classes are, I think, are a 5-point thing. So normally AP classes bump up GPA.
Okay. So I just wanted to make
Actually,
sure
that does muddy the high school GPA variable. It's no longer a 4-point scale. If I plot a graph of my incoming physics students' high school GPA, its maximum is at 4, with its max around 4.5 or 4.6. So
these are all STEM students, right? These are all people who took calculus.
These are, yeah, all STEM students. These are all physical science and engineering students. So these would be math students, chemistry students, physics students, or engineering students.
Okay. So yeah, and no, we did not catch the biology people here.
I have some biology people in the next talk. So.
Okay. All right. So go forward. Sorry.
So this, the college GPA is their overall college GPA. Okay, so I'm going to give the talk that I probably should have given at the start of this, but I couldn't figure out which went in order. So just, we've been working on, like Roxanne and Margie, we've been looking at understanding rural, and I'd like to show you how far we've got over the last year. And so we drew a different data set. This is, we're going to restrict only to West Virginia students who graduated from West Virginia High School, who are first-time freshmen. And we did restrict it to US citizens. And then we windowed it so we stopped looking at students after 2014, so everyone has a good chance to graduate. And that gives about 11,000 students. We're going to divide STEM into these classifications. First, non-STEM. We're going to look at agriculture students, life sciences, which I will include health profession students, and some general science majors, but just a handful. And then the ones we were looking at before, physical science, which is engineering, math, chemistry, and physics. And this kind of division, really, these various classifications have different math requirements for their degrees. And last time I talked about first generation with this data set, but I'm not going to talk about first generation. This time I think we need more work on what rural means. We're also going to talk about being calculus ready. For the physical science students, they're considered math ready in college if they're ready to take calculus, either the 2-semester stretch course or the 1-semester normal calculus 1 in their first semester. So those students are calculus ready, then other students are not. And this was unreadable last time, it's still unreadable, but I am going to talk about 3 measures of virality. The first I talked about last time was from the National Center for Educational Statistics, and these are called locale codes. And they rate virality on a 12-point scale, which insanely goes 11, 12, 13, 21, 22, 23. And so down here at the bottom are the most rural, which are rural fringe, rural distant, and rural remote. And we're going to find, in West Virginia at least, the last 2 really work a bit differently than the first rural classification. Okay. And the census also provides a measure of the fraction of people in a county, and that's what I was using as rural fraction last time, that are rural, and they classify things as urban areas, urban clusters, and then other. And so we'll use this data to calculate the fraction of a county that is rural. And then what Roxanne talked about is the Department of Agriculture also has a rural urban continuum code that has a 9-level measure of virality. So first thing we want to know, okay, what does West Virginia look like if you look at these things, and how do they work together? So each of these are West Virginia counties. And this is the fraction of the county that's rural. And you can see that West Virginia has a lot of counties that have a very high percentage of their population in rural areas, which makes it a fantastic state to do this kind of stuff. This is the RUC code that Roxanne talked about. I don't know why you had 5, I have 4 here. I think I'm throwing away 1 county because we have no good data on it. So, but the RUC code's kind of all over the place, right? It doesn't have the nice, this nice progression in the rural fraction, and the RUC code is kind of bumpy. And then finally, this locale code from the National Center for Education Statistics is a bit more peaked too. And I flattened it. This is locale code 11, which we don't have any of. This is locale code 43, which is the most rural. And it's also kind of peaked around the the locale code of 41. We have a lot of Cal 41 high schools in West Virginia. And you can plot them against each other. This is rural fraction against the RUC code. And they are correlated, which is good. And here is locale versus rural percentage. It's also correlated. A little more. There's not as much outlier, right? There's all this stuff that's worrisome in the RUC code. Down here at 3. And it's a cleaner graph. Okay, so we have 3 measures, and we're gonna by and large use rural percentage. Well, we're gonna use both rural percentage and locale in this talk. Okay, so we can look at the rate students from different West Virginia counties elect majors at WVU, and this is broken down, and my group said this was readable, but I have agriculture majors in yellow, life science majors in red, non-STEM majors in blue, and physical science majors in black. And kind of not surprisingly, agriculture majors, more people elect agriculture for more rural counties. And I think somewhat surprising to me, less students elect non-STEM majors. So kind of physical science is pretty flat, just a slight increase in life sciences. And this is, once again, locale codes. This is the most rural locale 43.
The question is, in Roxanne's talk, she did 1 through 9.
Yeah, so this would be the RUC code. This is the locale code. So once again, here's the RUC codes against the percentage rural. And the locale code just looked a bit smoother. So I plotted this against locale code. The RUC code had this odd 2 maxima, which it doesn't have quite the same progression as the locale code. And locale code is nice because actually, locale code is a high school level. So one of our goals is to do this, not by county, but by high school, which I think will be more productive. All right, and then a table. So basically, these are the, not rural locale codes less than 41. Then this 41 that had a big peak, and then the very rural 42 and 43. And lots of stuff is, a little higher SES, low SES in the very rural counties, slightly lower college GPA, many less AP courses, about the same transfer courses, and a higher STEM election rate. So more of these very rural students are electing STEM majors. All right, now, do they graduate? So these are overall graduation rate in any major. And so as one becomes more rural, the graduation rate goes down, but not very strongly. That's not a huge effect again. And I don't know what's going on with this dot up here. I think there's only one, like a tiny number of locale 7 folks, but they all graduated with agriculture degrees. So kind of the same picture for everybody. Slightly higher graduation rate for the agriculture and the physical science students than the life sciences and the non-STEM students. All right, now kind of what we care about, what they graduate in STEM. So this is STEM graduation rate. For these are all students who elected STEM majors. And so I took out the non-STEM students. And the question is, this is graduation in STEM, this is graduating with a STEM major. Not necessarily the major you came in with, but a STEM major. And agriculture students are pretty constant. And life sciences goes on a little, but physical science is a little weird. If you look really closely, there's 2 dots there. So physical science is like totally constant. And then as you get to very rural, the graduation rate goes down. And I think that may be kind of showing you that we need to look very carefully at the effect of going up in a rural county who might have lower access to college preparatory coursework. So it may only be important for certain, majors with the most challenging degree requirements. And that's why we've been focusing in on the physical science students. And same, so you see lower STEM graduation percentage, lower graduation percentage. Yeah, so this does, so the question, I'll now take a question in the chat and become totally confused. To me, this does seem to indicate that focusing on perhaps physical science intending students in the most rural counties and making sure that they have as enriched a high school experience as possible might be a good strategy. But I think there's more that needs to be done.
And about 2 minutes,
the end values
Jen.
for the rural county. All right, the end values for the rural counties are lower, but still significant. We're starting with 11,000 students. So, oh, here are the, yes, we still are at 760 students in the very rural counties. Okay, so I think with 2 minutes left, I can put a few of these up, but I won't. So this, this is major election by county. It goes slightly more STEM majors for more rural counties. Slightly lower graduation rate, but really you can see it's a really small effect. And high school GPA, like this graph. And I think this chunk over here is probably, I'm guessing these are AP grades. That you're seeing the less rural counties have more AP classes, and that does inflate college GPA. College GPA is pretty flat. And I want to get, so this is AP classes go down pretty steeply with higher rural fraction. Transfer classes are weird, kind of flat all the way up to about 80% rural, then they go up steeply as you get very, very rural. And I think I will stop there. So I saw tons of questions in the chat. Which ones would you like addressed?
I think the ones we haven't got to, are we seeing any correlation between choice of major and first gen?
And first generation?
Right, so do more first generation students choose, it seemed like they chose more STEM. Was there a particular area of STEM?
Oh, that's a good question. I haven't broken down the, and we'll loop back to looking at first generation the next time I give this. I don't know if I broke down that by STEM discipline. We could also break it down by STEM major. There's some question, and we can also peel like life sciences and health sciences apart. I'm still not convinced looking at those two groups together is the right way either. All right.
Let's see. The online question, that's not really a question for the speaker. We can tell you what the counties are. Did we look at free and reduced lunch?
I believe that's one of the primary components going into the low SES variable that I presented.
Okay.
So that once again, that is a high school variable. That's not a county variable. That's the average fraction of students qualified as low SES in the county high schools.
Yeah. And, one of the things that's not included in here, obviously, are teacher expectations. We'd love to do that because there is some indication that higher teacher expectations lead to higher learning. Any question somebody's burning that I haven't asked? Because we need to move to our next.
I have a burning question that has to do with the first gen, but sort of more generally, how have we looked at first gen here as a factor with these other things? Or not?
That was presented last time. So that's why
yeah,
this time
so we
we're
looked
doing
at, there's a version of this talk from, Yeah, first gen was we're looking at rural primarily this time because it was very hard to understand. First gen was a pretty clear, as reported in lots of studies, there is a, first generation students are not quite as successful as non-first generation students in college. So, and I'm sorry, just would have to go back to the previous talk. I think their rates of selecting STEM majors are about the same as non-first generation students. With that, I would have to look back to last year's talk.
Yeah, our big problem with the first, or with the, was that if they left the major, they were less likely to graduate than people who weren't first generation to leave STEM majors. But we are out of time for this, and I would like to hand things over to our lovely project evaluator, Caitlin.
Hi, everyone. Thank you guys very much for a fascinating presentation from the research team. We clearly need to get together and have a data party and talk all of these things out because this stuff goes deep and it's good. Anyway, I'm Caitlin Howley. As Gay said, I am on the research team, but before we get going, I would like you to please stand up or at least stretch, move, and then I'm going to ask you to take a short poll because we would like to understand how much you know about what your experience is with program evaluation, which is what we are going to talk about. So if you would please take the poll, it'll give us a sense of whether you're friends with evaluation or frenemies or you don't know who evaluation is. Can you guys see the polling? Yes, okay, all right. Well,
I can't see the results.
Oh, how do I show the results?
After you end the poll, you'll be able to share the results of the poll.
Oh, okay. So I'm getting a preview. You don't know what the data say yet, do you? Ooh, I like having a secret. All right, I think we're close enough. I'm going to go ahead and end the polling. And as you can see, it looks like nearly half of you have been involved in evaluation before, and it was pretty cool. So we do not have a whole bunch of people here who are licking their wounds. Nobody said that they've met evaluation but don't get along. So that is excellent. I'm delighted to hear that. And 2 of you, on the other hand, really have never met evaluation. So we will introduce you very briefly to evaluation, which is using social science research methods to understand whether a program like the First2 network is working. Is it achieving its goals? Is everything going smoothly? Are there people they're not reaching? It's also like I tend to think of evaluators as your friends. Yeah, we might ask some difficult questions sometimes, but it's really there to help you do what you do even better. So very briefly, that is what evaluation is. So I will now invite you to please go to your top right corner where it says speaker view or gallery view and select speaker view so you can see the 2 experts that I am going to introduce you to shortly. So I would like to let you know that today, although I am a member of this august evaluation team, today I am playing a journalist on this webinar. I will be asking our 2 evaluators questions and inviting you to ask them questions as well. If you're not speaking, please mute your microphones and we will get started. Do you see my slideshow? Yes, excellent. Well, I'm Caitlin Howley again, as I said, and I am delighted to introduce you to our experts today. They will tell you a little bit about themselves, briefly answer to the question, what are we learning and where are we going? So funny you should ask. I'd like to introduce you to Dr. Jonave Campbell. In a minute or less, Jonave, can you introduce yourself, please, and let us know, do you have a nickname?
Sure. So I think what's fascinating about what Caitlin said and about the field of evaluation, specifically on our ICF team, is that people come from many walks of life and just to land in this profession of evaluation. So I'm actually a trained mechanical engineer. I worked for Equilon Oil Company at one point in my life, also General Electric. I turned into an educator. I taught math for a stint. I also taught some English as a second language courses in Guinea, West Africa. That is next to Senegal and Ghana, for those of you who are unfamiliar with the West African region. And then I became an evaluator. I'm a trained evaluator at the University of North Carolina, Chapel Hill, where I pursued my doctorate degree in that area. My family would call me as a child, shortening my name, they, but my dad liked to say Bebe. So if you are unfamiliar with the term Bebe's kids, I get teased quite a bit for my 3 children and them being Bebe's kids. I think that's it.
Thank you. That is very interesting. You have transformed yourself. So this seems like a good place for you to land as an evaluator. Thank you. Oh, shoot. I'm on TV. I forgot to put my makeup on. While I'm doing this, I would like to introduce you to Dr. Kimberly Cooley, who is also a member of the evaluation team. Could you tell us in 1 minute or less, Dr. Kim Cooley, a little bit about how you got into evaluation, and also, do you have a superpower?
Okay, so hi everybody. Just like Jonave, I kind of came into the world of evaluation through a back door. I started out for a company many moons ago, serving as a secretary, and after typing about probably 1 billion evaluation reports, I was like, I think I like this stuff. I think I'm starting to understand what all of these statistical things mean. And so I kind of progressed from typing to starting to go in and have conversations with whoever the author was about, what does this mean? And did you really mean to say this? And just kept learning and growing, and went back to school part-time and finished up my doctoral program, and just became very excited and passionate about what has become kind of a lifetime commitment to evaluation. So I guess that kind of is now my superpower, all things evaluation.
Thank you very much, Kim. And I think that you too came by a path really meaningful for this particular project. So I bet that you and Jonave have some unique insights into this project, but maybe we'll talk about that later. So let's go ahead and move on to some of our questions about what you learned from the year 2 evaluation of First2. Kim, would you care to begin and let us know what one key insight you'd like to share?
Sure. We've collected a ton of data this year, and one of the things that I was able to be involved in was talking to the staff at the West Virginia Higher Education Policy Commission about their roles with the network over the past year, and how that work had kind of changed and evolved. And I was really struck by the growth that was evidenced over year 2 in their capacity to serve as the network's hub or backbone organization. Somewhere around the end of year 1, beginning of year 2, they reallocated their staffing, and we now have Jade as a full-time network program coordinator. They worked with their mentor hub, SRI, to better align the capacity building supports that were provided. They streamlined communications within the network. And also during year 2, a network strategic plan was created. So all of that just really points to, I think, to major strides in enhanced capacity.
Yeah, that sounds really important. Thank you, Kim.
Yep.
Jonave, one key
Sure.
insight you'd like to share.
Sure, yeah. I would probably just confirm what the social network analysis data alluded to in terms of the leadership and network and how they play such a vital role in member activity and value associated with the network. First2 just continues to be led by a group of committed individuals who take the initiative in the organization of First2 change activities. And whether it's incentivized or not, it tends to be greatly appreciated to have that leadership and organization at the helm.
Thanks, Donovan. And I'd like to kind of build on that and ask you, about what happens in working groups. I mean, that's a core part of what First2 does. What did you learn this year about some of the working group successes and maybe some of their challenges?
Sure. So first off, I will say, you'll see the slide in front of you. It basically is a response rate slide. And what's that saying? It's saying that there's more engagement, more activity in terms of the working groups and in terms of their comfort with completing the working group survey. So many cases, I think the first year when we did the working group survey, we just required everybody to fill out everything. We got a little smarter, and towards the second quarters, we started putting some skip logic in our surveys that allowed them to skip sections they didn't feel comfortable or could not respond to. That being said, even with the skip logic, there were quite a few who felt more comfortable answering questions around the Plan, Do, Study, Act cycle, more so than they did previously, which speaks to their engagement in that activity. Collaboration has always been a strength of the network. They continue to answer those items consistently, and that area continues to grow. Equity is one of those areas we can talk about in a moment, and then building capacity is growing in certain areas as well. But overall, there were at least 40% more who took the survey by the final quarter. So in terms of key takeaways, I mentioned collaboration. It continues to be a strength of the network. I said that I think overall, we're talking about the ability to respect one another and the roles that they have in the working groups. We're talking about the ability to recognize the value that each member in the working group has. And so that is really strong. And that has increased. Another one of the important strengths is the working group's ability to ensure student perspectives are considered. That has grown over time, and I think that's worth noting. In terms of the PDSAs, members reported more activity. I mentioned that. The real natural occurrence with regards to PDSA activity is that the Plan, Do gets started first, then you move into the study, then the act, and it's a quick cycle that keeps repeating itself. So we would like to see working group members and working groups focus on that, that continuous learning cycle, right? As it relates to the change activity. We don't want to see them get stuck in a plan for a whole year. We don't want to see them get stuck in the do, right? We want them to also not jump from plan to act without doing the study. So what we're looking for is that they're comfortable. Moving on.
I'm going to provide you some evaluative feedback and ask that you talk faster.
Here we go. Dissemination. Still developing. Not as strong, but that's natural because there's not a lot of opportunities yet for them to share between groups. Within groups, they're doing a better job. Building capacity, members are taking on new roles in the group, but expanded partnership and diversification of institutions is important and needed. Finally, reflecting on equity, mixed emotions about this has a lot to do with the representation of the working groups and the people involved. That's it. Next one.
Thank you. And I really appreciate the way you modeled accepting feedback. All right, so you guys, I know something about evaluators that you all might not know, which is that they're also real people. And so I would like to ask our experts here to put aside their evaluator roles for just a minute, and let us know, what is your personal favorite thing about the First2 network? Kim Cooley.
Oh, I think it's so near and dear to my heart because I am a native West Virginia, and I am a first generation, or was a first generation college goer. I mean, nobody in my family had ever done anything college related. I was not involved in any kind of college prep in high school. I was business track all the way. And so when I first started dabbling in college waters, it was so foreign to me. And if I hadn't had my mentors at my employer's agency, I, I wouldn't have had any insights. And so it's just near and dear to my heart.
Thanks for sharing that. How about you, Jonave?
I would say the reliance on the student voice in terms of their activities and their decision making. I think that has always been a central focus of First2, and they're getting even better at it. And so I think the ability for the faculty and the staff and the organizational staff to be able to use the student feedback that they receive from students, and for students to play a critical role in the project work, it's very inspiring.
Thank you very much. This should never happen when you are doing an interview, but I seem to have misplaced my next page of questions. So I am going to ask Kim Cooley to remember what it is that I was going to ask her here.
Oh, I would love to remind you. We're going to talk about the focus groups that we did back in the spring with the year one interns. And so this was a new activity that we wanted to incorporate. And although originally these were intended to be in-person events, we know what COVID has done. And so they turned out to be virtual group discussions with students who had participated in one of the 4 2019 research internships. So I was able to get 23 students all together across those 4 groups, and we did hold them individually by site. And the one thing that we asked them when they first joined the webinar was, give me a one-word description of your experience in the First2 network. And you can see the little word cloud there. It's so powerful because it's so positive, supportive, and unique, and amazing, and eye-opening, and it just speaks to how the network is able to broaden horizons, so to speak, and to help students get more centered in their STEM worlds. And so when we ask them, you know, what's your main reason for joining the network? They talked about the research immersion experience, giving them the opportunity to be involved in research activities before they went to college, and also to start meeting and networking with their peers, with their professors and faculty members, and just starting to get to know people before they landed in college. They also identified the networking aspect of the network as a whole as one of the most valuable components to them. So a lot of value there. They also talked about how the internship experience helped them identify contacts within their STEM majors, helped them strengthen their desire for a particular STEM major, and then also open them up to new areas of interest within those majors. And then also, beyond just the internship experience, they reported that it increased their confidence to do their STEM coursework. So they were feeling better about their abilities to do that level of work, about what to expect in the classes, to give them a little hands-on research experience before they got there, to increase their confidence even in the research topics that may come up, and also to build relationships. But there were some challenges. When I asked them to identify the roles that they played within the network, there were lots of different roles that bubbled up. And sometimes the students themselves couldn't parse out what is the difference in one title versus another, and were you the same thing as I was? Some of the students reflected back to some of the chemistry research activities during their particular internship that they thought maybe could have been a little more robust. And then some of the students also talked about some confusion around the application process, whether that was not quite understanding how to differentiate which role they wanted to apply for in the network, or what some of the terminology might mean, or even some of the language in some of those introductory emails. And then student voice, it was kind of mixed results. Some of the students reported their individual voices were heard, Some were less confident that they themselves individually had much of a voice, but that other students had more of a voice. And some reflected that even if they think their voices are heard, they're not sure that always actually affected any of the network decisions. And then the last quick little challenge, some of them reported difficulty in getting reimbursed in a timely manner. So I think that wrapped it up.
Thank you very much, Kim, and I am delighted to report that I have found the missing questions.
Okay.
I believe that was too much drama for me. Now, moving on. So this summer was, it was something else. All of the first two internships became online experiences to accommodate the social distancing that was required to keep everyone healthy and safe during the pandemic. So I'm curious, what did students think about these experiences?
Okay, so yeah, there were 9 sites this summer. They all had 2-week virtual internships. And we provided a survey for students at the beginning and at the end of the 2 weeks. And the items were grouped into these 9 subscales that you'll see here. Some of them were on a 1 to 5 agreement scale. The others were on a 1 to 5 scale of no knowledge or skills in this area, to 5 being a great deal. And for 6 of the 9, or excuse me, for 7 of the 9, we did see an increase. This is showing the change scores right now. So it's not on the 1 to 5 scale, it's the amount of change from pre to post. So from beginning to end at the 2-week session. And these actual change scores are focused on those 58 students that we were able to match pre-test data and post-test data. So 6 of those 7 increases, the dark blue columns, were actually statistically significant. The STEM efficacy was not. Oh, I see waving of hands. Do I need to move along?
No, that was excitement.
Oh, okay, okay.
That was...
Okay, she's doing the happy dance. Okay. And then the 2 on the end in red were very slight decreases. But again, the 2 red and the light blue were not statistically significant and was just kind of a little bit of noise. And then on the post-test survey, we added 14 items to give students the opportunity to rate their experience in the internship. And so I don't have all 14 of them on this graph, but I have the top 5 rated, and then I have the lowest 5 rated. This was on a 1 to 5 scale of agreement, so 5 is the best. And you can see that even the lowest was a score of 4.0, which is in the agree range. So these were really highly rated. The one thing that was the lowest was the virtual structure, which we can kind of expect. But looking up to what was nearly a 5.0 is that they would recommend it to others. It increased their knowledge of research. It improved their research skills. So lots of good things about the internship. And I just wanted to throw in a few quotes so you could hear directly in the students' words what they had to say about that experience. Very, very positive. I won't read those. I'll let you read those to yourselves. But there were a few challenges as well. The items that focused on recruitment and application process, those were some of the lowest rated, even though they were still, above a 4.0, those were the lowest rated, and it kind of aligns with what our year 1 intern said in the focus groups. And then also the students identified and recognized that the virtual setting was mandatory, right? But that given that, they could have, they would have liked to have seen more hands-on activities, more of those small group sessions where they could talk amongst themselves, and perhaps fewer of the full group sessions and a little less screen time. So those were the challenges that they identified.
Thank you, Kim. That was very informative and also very concise. I from evaluative feedback, so that's really excellent to see. Okay, audience, I am going to now take you to the backstage of being an evaluator, because I know that you all have wondered what it is like a day in the life of a program evaluator. So I'm going to show you a little bit of it. One of the fun things about being an evaluator is reading replies to open-ended survey, interview, or focus group questions. And sometimes, not always, but sometimes respondents will say funny things. So for example, a colleague of mine once asked a group of kindergarteners if the students knew who the superintendent of their school district was. And one kid replied with a question. The kid said, well, if he's so super, why don't they call him the perfect intendant? So my question for our expert evaluator panelists is, could you share with us one funny answer you've gotten to a question you've asked in a survey or during an interview or focus group, not necessarily in First2, but in any project or program that you have evaluated?
I will say I've gotten a lot of inappropriate responses. Does that count?
Yeah, I have one that's not ready to share in prime time.
I get students quite a bit that say irrelevant or unnecessarily, you know, inappropriate things to respond to things. But in terms of just actual comments that are actually authentic and that are trying to answer the question, I think most people do their best. I'd have to think a little bit harder on stuff that's
all right. This live television thing, I know is hard for people, so that's all right. But I just want to show you that evaluators have a little fun too. It's nerdy, it's not for everyone, but that is something that we do get to enjoy every now and then. So moving on, in addition to the work of that the First2 network does with students, a lot happened this year in terms of inviting more people to the network, improving communications, sharing information about good ways to improve STEM persistence, and preparing the network to sustain itself after NSF funding comes to an end. And all this while a pandemic is going on. So, Jonavay, can you tell us a little bit about what you learned from an analysis of the data from the network value survey? What did people report that they valued most about their participation in the network?
Okay, great. I actually prepared a slide to help illustrate a little bit of some of the highs in terms of each area of the value network survey. And so for those who are not as familiar, this speaks to a value story that progresses as time goes along or as activities become more expanded or in-depth. Okay, so the first two areas that you see that are green starred are where most of the occurrence of the value is placed. Okay, so members show quite a bit of immediate value, specifically engagement and network activities. In terms of the ratings were high in that category, and they made connections with colleagues around shared goals. And this was for both student and non-student respondents. So that's very important to note. The second progression of the value story is really about gaining new knowledge, okay, or skills as it relates to their own individual or professional growth. And this is also an area that had some strong ratings, gained access to new tools, information, or processes that would not have access to otherwise, gained insight about a person or group they can turn to for information or support. And I will say that in terms of the student versus the non-student respondents, students had a higher rating as it related to new skill development compared to a non-student member like a faculty or staff. But faculty and staff tended to have higher ratings when talking about the value of access to professional relationships that would somehow influence their perspective in some way. The third area, which would be applied learning, okay? So this is some positive things that came out of here, although not as frequently mentioned as valuable yet. We would like to see it be more valuable later, is use a document produced or made accessible by the network. That was highly rated in this area. Used knowledge or skills obtained through the network to better understand problems or issues impacting first generation student groups. And I got a lot of comments, I will say, in this area, specifically from faculty and staff who are using some of the framework that they're learning to apply it to other areas of their professional growth. We'd like to see more of that, but that's just an example. And then the fourth area is really about performance improvement. How are these activities in your applied learning being translated into your organizational structures and your own performance as a professional? Are people seeing that difference? One of the areas that did get a rating that was positive was encountered evidence that the network has advanced its reputation, although it's not frequently mentioned as a value yet. We would like to see more activity in that area. So we're still waiting to see how this is impacting organizations and the work that they do. Influence and redefining success would be the culmination experience that we're looking for. And one of those areas is demonstrated an understanding of the complexity of elements important to students' pursuit of STEM careers. And that was a higher rated area, and it was a new add-on for the last couple of surveys from the last year. So we'll keep that on there to see how that's growing in the future.
Thank you, Jonave. So Jonave discussed what people value about the network, but let's get really nerdy here, Kim. Can you show us how the network has grown between year 1 and year 2? Like, do you have any nifty social network maps or something, like maybe that somebody stole our thunder earlier on and shared with us?
Yes, I'm going to try to build on what Margie already shared this morning about social network analysis. So basically, again, social network analysis helps us to analyze network size, number of members, strength of connections. In year 1, we did have 25 people complete the survey. In year 2, 32 members completed the survey, so a slight increase, yay. And again, it asked members to identify up to 10 other members that they engaged with or communicated with on issues relevant to the network, and then to also rate the strength of those engagements. And so Margie's already showed you that was kind of a 1 to 5 scale of engagement. And I just wanted to share a little bit more detail about what those differentiations mean. So starting at the weakest level, level 1, networking, is you're aware of what the network is. There's some loosely defined roles, but there's not a whole lot of communication back and forth. And then you move on to cooperation, where you have some shared information. The roles are getting a little clearer, and you're starting to have some independent decision making. And then you roll into level 3, coordination, where the roles are pretty well defined now, and you're starting to see some shared decision making. And on to coalition, which is frequent ongoing communication, sharing of resources, sharing the decision making, all the way up to that top tier, the most strongest of collaboration, which is not only the shared resources, it's mutual trust, it's coordination on most or all of the decision making. And if we could go back to that slide just for 1 second, I wanted to point out coordination is in red. That is the 3rd tier, and that's where we kind of landed overall, looking at the year 1 data, right around a 3.11 average score across all of those network member engagement ratings. And so in year 2, we're still hovering in that coordination area, but the actual mean score did increase just a bit from 3.11 to 3.34. So we did see a little growth there. And so then another way to visually depict the information is through these star graphs. So hopefully Margie didn't show these. I don't think she did. So we got a little bit of new information here. And you can see the 2 graphs. Year 1 is on your right, year 2 is on your left. And you can see that there are more of those circles, nodes, or actors, or people in all of this SNA language. And there's also more connections, right? And some of those connections, those levels of engagement, are at a stronger level. And so the lines are a bit thicker. And so I don't know if you can see the organization piece where we graph this one out by color coding the 5 key PI institutions for the First2 network. So we have WVU in blue and Fairmont in the maroon, and HEPC is the yellow, High Rocks is the light blue, and Green Bank is the green. And then all of the other members from other institutions are the clear color dots. And so I know it gets really hard to see because this is a really small graph, but just to point out that we are seeing more people in the network, more members, more interactions among those members, a higher level of engagement overall. And so all of these are positive indicators on how the network has evolved and shifted from year 1 to year 2. And of course, we're going to keep tracking that throughout each year.
Thank you, Kim, and thank you for having some exciting graphics that Roxanne and Marjorie did not have. Kudos there. So something that we evaluators notice about groups of people, whether they're families or they're the First2 network, is that they tend to develop their own insider language, and it can include jokes or acronyms, shorthands, made up jargon, for example. And I will say that we've noticed that the First2 network definitely is developing its own personal lexicon. So I wanted to ask, what are some of the words, Genevieve and Kim, that you've noticed that have developed amongst the First2 network?
Some of the, say that one more time.
Some of the specialized words, language, jokes, jargon that the First2 network members have developed.
I think the one that comes to my mind first is the words I've heard bandied about adultier adult, which I think kind of emerged from trying to differentiate a bit between the students who are also adults and the more seasoned, shall we say, others who are maybe just a little adultier in terms of longevity.
That's a good one. Yep. Donovan, can you think of any?
None that are new. I mean, I think, you know, I think there's a lot that comes up when the students are speaking. I can't think of it off the top of my head, but student voice is a big one. But if I think of them, I'll let you know in the chat.
Yeah, again, this live television is not for everybody. I understand that. I think some of my favorites are when we're talking about things like coordinating activity or communicating across groups. That kind of activity is described as backboney. I like that. I also like how doing PDSAs has turned into a verb. So now people say that they're PDSAing. Anyway, we noticed and we wanted to. So Kim, I have a really big question here, and it's maybe one of the most important questions, which is, so what? You know, so network members did all this stuff this year, but to what end? And what impact does the evaluation suggest that the network made this year?
I think we can point to several areas of impact, trying to roll up everything that we've collected information on this year and sorted through and steeped ourselves in the results. Pretty much boils down to, we're seeing for the year 1 interns, the 2019 interns, for those we were able to track this level of data on, of the 30 that we tracked, 24 actually persisted in a STEM major between fall of 2019 and spring 2020. So you have a STEM persistence rate of 80%. And then just as a point of a proxy comparison, the West Virginia rate of fall to fall re-enrollment in a STEM major amongst rural STEM students who were eligible for a Pell Grant was 74%. So if you could back up just to that last slide, Caitlin, just for a sec. Just want to go over a couple of pointers there. So we are seeing a slightly higher First2 STEM network persistence rate. Compared to year 1, the network now has more members who are engaged in more networking and stronger levels of engagement. Given that most of our network students are rural and first generation, They're unlikely to have been previously embedded in some sort of STEM network or support group, and they now have that opportunity throughout the First2 network. They can build those relationships throughout the network. The interns from year one increase their confidence to do STEM coursework, and their ongoing support from the network helped them to progress and persist throughout their STEM studies. And then this year's interns increase their sense of school belonging, their STEM identity, their STEM efficacy. They increase their knowledge and attitudes about research, and improve some of their personal and research skills as a result of the internship. So all of those kind of point to the impact. And then just to kind of give you the lay of the land of West Virginia, some state indicators. We see the First2 network aim is over the next 10 years, we want to see that graduation rate go from 30 to 60% of students who enter college with a STEM major and who graduate in 4 years. And so just to show you where we are kind of as a state right now, and this is all thanks to Zori at HEPC. She is so amazing to help us parse these data out. Pell eligible youth and minority youth had lower rates of readiness, persistence, and completion rates compared to their non-Pell or non-minority counterpoints. STEM students have higher rates of readiness entering college and persistence rates than non-STEM, but yet they have lower completion rates. In terms of gender, females had lower readiness rates than males, but yet higher rates of persistence and completion. And then when we look at by rurality, there's less of a trend. There's fewer patterns there at this point that we can speak to, but in general, most of the freshman cohorts that we looked at had rural youth had slightly lower readiness and persistence rates than non-rural youth. So we're going to be tracking all of this information throughout the project as we keep our eye on that one big metric of, are we actually seeing that needle move from 30 to 60%? So I think that's it.
Thank you very much. And that's important. We could, again, like with the research team, we could spend hours talking about the other things that the data say. So we tried to, well, we tried to ensure that it could fit within the time frame of this television show. So, but now we'd like to ask you if you have any questions. So if you'll please unmute yourselves if you have a question, and please ask what you like of these fine evaluators.
So I see one question from Erica about, do we have Pell who are also STEM? And we do have some of those deeper breakdowns. And so we do have rural STEM versus rural non-Pell. And so all of those breakdowns we have in some tables that we were able to prepare from the data that Zori had shared with us. So all of that is in the year 2 report. And I know last year the year 1 report was actually posted on the First2 website. So I don't know if the year 2 report has been posted yet, but if not, I'm sure that's something that could happen so you can dive into a lot more of these details.
Yep, thank you. And you know you have a good evaluation team when your evaluation report comes in 2 volumes. Other questions? Feel free to ask.
Do you have any demographic information on the network as a whole? Can we look at?
That is a remarkable question, and funny enough, I do have some information about that, Erica. As you can see, these are year 1 and year 2 demographics. We doubled, well, we hugely increased our network size from, I think, what was it? It was 97% increase in membership between the years, from 144 in year 1 to 283 in year 2. Students are about 50% of the measurement at this point. There was also a 157% increase in the summer interns served, from 30 in year 1 to 77 in year 2. But you can see some of the breakdowns here. 29% of network members are university faculty or staff, 4% each are K-12 teachers and state government reps, and 3% represent education nonprofits. In terms of the interns themselves, they are very diverse. In fact, somewhat more diverse than West Virginia overall. So 9%, for example, identify as African American. At least 43% are eligible for Pell Grants, which is a proxy measure for low-income status, and 64% are first generation, and 47% hail from rural communities. Great question. Any other questions? Feel free to speak up.
Kim, you talked a lot about the student feedback that you got, which was really super interesting. And I'm wondering if, as evaluators, you have some ideas for improvements that the network can make. We're in year 3 in terms of how we work with the students.
Kim, you are on mute.
Sorry, my dogs were voicing their opinion, and so I muted myself. I was saying, thinking back to the feedback we got from students in the couple of different ways that we captured that information, and based on some of the challenges that they acknowledged, I think some suggestions moving forward, and I think some of these have already taken place, things like setting up direct deposit for student payments. I think that is either underway or already done. I know there's been some work recently about condensing the number of student roles and getting that a little clearer. Thinking that, you know, nothing is ever totally perfect, right? So perhaps there's some more refinements that can be made in terms of the recruitment and application process and the communications related to that. Some of the students had suggested that they would like to see network support open up in 2 more areas, not just the heavy concentration on like chemistry and biology, but also support for computer science or math or engineering. I think we can see one of the strengths that we've talked about a lot is how integrally involved student voice is in the network, but I think based on what we're hearing from some of the students, we still have some ways that we can continue to focus on and increase our commitment to incorporating student voice throughout the network. And then finally, you know, in a perfect world next year, we'll be able to do those research internships in person, right? But if not, if we're still stuck in a virtual mode, then just keeping an eye to what can we do to embed, you know, more of those small group sessions where students have the opportunity to interact more with one another and be able to talk perhaps a little more freely, and more of those hands-on activities and fieldwork activities that they really got into. So those are probably the things that stand out most immediately.
Thank you, Kim. Other questions?
So in the evaluation report that you guys just wrote, which was lovely, if maybe lengthy, I was reading about STEM social capital. And I was wondering if you could tell me a little bit more about what that means and what it means that you guys found so much evidence, some increased evidence in that arena this year.
Jonathan, I think I'm going to throw that one to you.
Jonathan, you're muted.
Oh, here we go. Okay. Do we have any slides or anything about that one specifically?
Nope.
Sure.
You're freewheeling.
Okay. So not ready for that one. Give me a second. What it means to, okay. So social capital itself, a lot of us may be aware of its the ability to have this network of individuals, right? This identity as it connects or interacts with individuals or resources, okay? So STEM social capital is specific to science, technology, engineering, and mathematics. So the ability to be able to have professional and personal connection with and interaction with resources and people in a way which you identify, right, becomes a value. And that value is termed capital, right? And so specifically, I think the First2 network, what it's been able to do, I know specifically from some of the working group surveys or the value network survey, what we've seen is that role of professional interaction and professional networks building, those relationships playing an important role in both student development in that area of STEM social capital, as well as professionals. The faculty and staff have grown quite a bit in terms of their own STEM social capital as it involves their relationship with one another and their relationship with students in that area. But in terms of First2 generation, I know as a First2 generation student myself, I didn't have the level of social capital when I was a high school student, but as it became more important in an undergraduate career development process, that's what gets you through, and that's what helps you persist to finish that degree. So between your staff, your faculty, your engineering student network or your science student network, that gets developed over time. Hope that helps. Does that help? That was off the cuff. So.
Thank you so much, Donovan.
It was good. Yeah, you might be cut out for this live TV thing after all. All right. We are nearing the end of our time. If you have any questions, though, we'd be happy to stick around and chat them out with you.
There were a couple in the chat.
Okay.
Oh, did we miss some?
Michelle put in pretty detailed questions there if you want to find them. I'm looking for it. It's hard to get back to.
She specifically asked if we, to clarify the social network analysis, research and evaluation, we're looking at different things. The numbers seem different for that reason. Oh, that was a response. Okay. And then Catherine said, maybe you already said this, but have you been able to interview the students that left? I know it's hard to track them down.
No, we have not interviewed students who were not still involved.
Although I believe that the research team is considering doing that.
Yeah.
Margie shaking her head.
We wanted to, but we weren't able to get anybody to respond. So we will keep at it, but it's how it, and we can look things up about where they went if they're in certain systems, like if they change their major.
Michelle did ask, is data being collected on members in terms of the network's effects on the members who are doing the work either as part of their job or on a volunteer basis, positive aspects and other aspects that are perhaps less positive? Would it be important to look at this in terms of sustainability of First2? I think that's a great question, and I'll let my colleagues speak to it, but I do know what I've been able to glean from some of the open-ended as well as some of the rated comments was that it does, for some, impact their professional job, not always positively. And I think it has to do with time, workload, were some of the things I was able to gather. It may have an effect on sustainability. I think it just depends. What I'm understanding is that people are shifting their priorities as it relates to their professional lives.
Thank you, Donovan. I'm sorry, we have so much to say, and I'm sorry to do this, but apparently the priority now is to go win prizes. So y'all go away.
Go away and come back.
Session. And if you ever have any questions, we're around. Feel free to email, call, or whatever. We will answer. Go win prizes. Bye.